Hopefully we are now at the point, or we're getting to the point where we have a range of strategies we're comfortable with in terms of solving equations. And now we want to use those strategies to solve equations. Uh, the unknown, so the value we're trying to find, the x is on one side at this stage, but there's brackets. What do you do? And I'm gonna throw out there to offer you to say pause and just have a go. Do what you think you should do. But I've labeled these as E1 examples. Sorry, so I'm gonna go through them. But as I said, you pause, have a go. Use the power of the pause. You have a go. Try to do the questions. Or even if I get started, as I progress, and you get to a moment where, oh yeah, now I know what to do. Then pause the video again, do it for yourself, and compare, see if what you think you knew what to do is what I actually did, and that's where you'll have the most powerful learning taking place using this online video as a tool for your learning. So right, with that in mind, you have your date. You type, if you don't have the date, if it's a new day you're doing these, you're writing down the date. DATE stands for date. You're writing down the title, task 43, and so objective to be able to solve linear equations with brackets. That's what we're looking at. That's what we're looking at initially. So let's get going. I'm going to use all, we can use all the methods: function machines, balancing, change the side, change the sign. So I'll do one of each. Is that so? And also you can see, hey, free choice. Now in terms of, let's think about problem A as a function machine. X is our input, so X is what we're using first. But what's the first thing that needs to happen to X? What does that bracket do? It changes, it has an impact on the order of operations. So what's happening to my number first based on the brackets? That's right, the first function, the first operation is the add 3, not the multiply by 4. Multiply by 4 comes after. That number is multiplying the entire answer from the bracket. It's multiplying x plus 3. So times by 4 is my second output. Second function, and then the output is 20. So this is for part A. Let me just make that clear. Okay, so this is for A. I've set it up as a function machine. Now that I've set up a function machine, to find the value of x, I need to go backwards, divide by 4, and take away 3. So 20 divided by 4. How many 20s are in 4? How many 4s are in 20? 5. And then 5 take away 3 will give me 2. So we're saying that x, the input, is 2. Let's check. 2 plus 3 is 5. 5 4s are 20. Correct. The function machine method works. Once the unknown is on one side, you can use that function machine method. It's when the unknown is on both sides, that's where the function machine strategy falls down. Now, part B, and I'm gonna need space for this, aren't I? So let's see how I'm gonna do this. I'm gonna duplicate this page. I'm doing things differently to originally plan, so gotta make more space. So we're gonna do B now, and so I have a copy, yeah. And so we know answer is 2 for A. We use the function machine. For the next one, we know the answer is 2. Going to leave that 2 there. X equals 2. Let's do the balancing method for B. And the first thing I'm going to do in terms of balancing, in this particular case, I looked at 35 and I saw the 5. I have 5 being multiplied by the bracket. I saw the 35 and I thought, well, hang on. Hey, 35 is in 5 times tables. So what I'm going to do first is I'm going to divide by 5. I'm going to divide both sides by 5. Yeah, you can do that, but you can't do that all the time. So we're going to talk about that in a moment. I'll do these questions. I just want to show a range of methods before I let you practice. The symbol here, you'll see that 6 is outside of the bracket, so the bracket is being multiplied by 6, but 50 is not in the 6 times table, so for C I can't use this method. But what happens here? When I divide both sides by 5, I now end up with the 2x take away 3 on the left-hand side. And on the right-hand side, I have 35 divided by 5, which will give me 7. My money says you probably were thinking, and you probably have done, those have done it, did he expand the bracket? Right. And that's what I want to get through, that there are cases when you don't need to worry about expanding the bracket. If you do the division first, divide both sides by the expression outside of the bracket, the term outside the bracket, in this case 5, brackets are gone. Now we just have 2x take away 3 equals 7. And working my way down, I'm going to add 3 to both sides now. I'm going to add 3 to both sides. So I get 2x is equal to 10. And then finally, I should have done a different color for the adding 3 as well. I'm going to divide both sides by 2. And that will give me x is equal to 5. So my answer, x equals 5. I think that's my answer. I'm going to check to make sure. And I substitute 2 times 5 is 10. 10 take away 3 is 7. 7 5s, 35. Yes, yes, we're correct using the balancing method. Finally, and I'll shift all of this a little bit just to make some more space. Whoa, I did not expect that to happen. Gonna shift a bit. Yeah, just making some space there. The 5 needs to go as well. Okay, right, so we got that sorted. X equals 5. And for the last one, I'm going to do this as change side, change sign. But before I do that, I need to expand the bracket. And I'm going to expand the bracket because 50 is not in the 6 times tables. I can't do the divide by 5. So expanding the bracket, remember, expand means to multiply out. So 6 multiplied by x is 6x. And then 6 multiplied by positive 7, 7 6 is 42. So plus 42 is equal to 50. I expanded, I multiplied out the bracket. At this stage, after multiplying out the bracket, it's like, well, this is like the stuff we were doing before. And you know, I'm going to do change side, change sign. So that plus 42, I'm looking at it and I'm thinking, well, hey, that needs to go on the other side and it needs to become minus 42. So on the right-hand side, let me shift a little bit to make it clearer. On the right-hand side, I'm going to end up with 50 take away 42, and 50 take away 42, that's going to be 8. On the left-hand side, I have 6x. I still have 6x, so 6x is equal to 8. 6x equals 8. Yeah, that's what it is. 6x is equal to 8. So I will divide both sides by 6. And I end up with x is equal to 8 on 6. And you're going to look at that and you're going to tell me, hey, you can simplify that fraction. Or you can write it as a mixed number. And I'm going to tell you, yeah, all of that is true. But I'm also going to tell you, well, the question just said solve the equation. It didn't tell me give the answer in its simplest form. It didn't tell me give the answer as a mixed numbers. So I don't have to. But you know what? I'm going to do it anyway. For this time. Under exam conditions, will I do it or will I play safe and save my time? I'll probably play safe and save my time. 8 on 6 is the same thing as 4 on 3. I divided both numbers by 2. Once you do the same thing to the numerator and denominator in terms of multiplication or division, then the fractions are equivalent. And that is 1 and 1/3 if I wanted to convert to a mixed number. Or what I would be careful, I was going to say 1.33, but you got this is where people run into problems. Going into decimal here, that's bad for business because you're going to lose accuracy. 0.33 is 33 over 100. 33 over 100 is not a third. What would you have to put as a decimal? 0.3 recurring. In other words, if you wanted to write this answer as a decimal, it will be 1.3 with a little dot on the 3 indicating that the 3 is recurring, it's repeating. That's what you'll need to do. All right, we've looked at different methods here. The function machine, that go back to the video if you want to see the function machine method used for A. I don't have space to keep it here. It's your choice. You can expand the brackets first. And if you expand the brackets, what are you going to do? You're going to use balancing or change side, or the function machine. It's your choice. But if you expand the bracket first, well, what's the point of using the function machine after? You could have used the function machine. What's happening here? I'm adding 7, then multiplying by 6. As a function machine, this was add 7, multiply by 6. Function machine method, balancing, change side, change sign. You make your choice. You decide which one is the best for you. Off you go. do these 4 questions. Okay, you got 4 questions to do. Use any method you feel comfortable with, because the unknown is on one side. You have the full range of methods available to you. Off you go. You pause, the power of the pause, and I'm going to give you the answers now. I'm going to give you the answers for these. Here you go. Those are the answers you should have. Okay? Those are the answers you should have. And we're going to move on. If any of these were issues, hopefully as we go forward, we'll plug them as you develop, or you'll be able to come back and think, okay, right, that's where I made my mistake. If not, get a teacher involved. And we can deal with that. Okay, so let's go to some others. Try these 2, please. Do these 2. Yep. Here are your answers. You did the pause. I'm going to give the answers now. Here are your answers. 43 on 10, 9 on 2. And in this case, I am going to do, in both cases, for C, you can do the division, because you can see 33 3 goes into 30. So I know for C, I can see that I'll have 2x plus 1 is equal to 30 divided by 3 is equal to 10. And then that's the equation you're solving. For A, not that simple. For A, you have to expand the bracket, or you use the function machine. Now, I won't use a function machine here because I'm seeing 3 processes. For the function machine, I got to take away 7, I got to multiply by 2, and then I got to multiply by 5. That's what needs to happen. Actually, what am I doing? I got that wrong. That's not what's going to happen for the function machine. What happens? The first thing is multiplying by 2. Whoa, what's the teacher doing? I got to multiply by 2, then I'm going to take away 7, and then I'm going to multiply by 5, and that will give me 8. And the reason I want to use a function machine is because, well, as soon as I start to go the other way, what happens? I need to divide by 5, yeah? The 8 divided by 5 gives me 8 on 3, fraction. Then I need to take away, I need to add 7, sorry. Do I really want to add to a fraction? And all of a sudden, I did that, and you probably picked up on it previously. Function machine method, when you're not getting whole numbers, not a lot of fun. Not a method that you want. So again, for the most basic of solving equations, using a function machine is a very powerful tool. But as soon as we get into the world of where we can have fractions, etc., as soon as the equations become more complex, the model is not as nice as you would like. Okay, so let us deal with the way I would do A. I'll use balancing or chain side. I'll expand the bracket, giving me 10x, and then I'll multiply out the 5, multiplying the 5 by the 7. Remember, expand means to multiply out to give me minus 35. So 10x take away 35 is going to give me 8. Then if 10x take away 35, so that's my first line, and I'll just run through this one quickly. And then if 10x take away 35, that's giving me 8. Then my second line would be that minus 35 needs to go over and becomes positive 35. So I'm going to have as my second line 10x is equal to 8 plus 35 is equal to 43. And then quickly you can see for your third line, x is going to be equal to 43 on 10, which is the answer we're looking for. So x is equal to 43 on 10. Let's just bring this down to make sure you can see what was happening there. X is 43 on 10. So you've seen 1, 2, 3, 3 stages of work there. Good stuff. Let's move on. Shall we move on? Example. These, what's the difference? Why am I doing an example of these? Because it always gets a bit funny. People start to think a bit uncomfortable when we have the negative x. When x is not positive, how did we deal with that? I just wanted to showcase some examples here. 7 fours, I'll expand the bracket. Should I expand the bracket? I changed my mind. I won't expand the bracket. Why? Because 4 goes into 20. So I'm going to divide both sides. I'm going to divide both sides by 4. And remember, you could have paused me. You could have paused me in my tracks, and you could get going. You get going. Try it. Try it for yourself. Don't just wait and see for me. Pause me. No, you get going. You get going. divide by 4, divide by 4. And then I get 7 take away x is equal to 5. That's what should happen. That's what you should get. Then at this stage, well, look at this. What am I going to do? Different ways you can do it. But if you were thinking about balancing, the way you would do this is you would add, where you could do it is add x to both sides. That's one way of doing it. If I add x to both sides, then I end up with 7 is equal to 5 plus x, because the x's will cancel here. And then I could take away 5 from both sides, because I want x all by itself. So I'll take away the 5 from both sides, and that leaves me with x is equal to 2. X is equal to 2 is what I get. And I can say x equals 2. And if I try it, 7 take away 2 is 5. 5 4 is 20. It works. Now, this is not the only order. This is not the only way you could have done this. You might have worked on it differently, but that's the concept of balancing. And hopefully it's showing you that, well, balancing, once you're doing the same thing on both sides, you can do, order doesn't matter. The order does matter. I was going to say order doesn't matter, but it does matter. But you have a lot of flexibility in terms of how you can do it. That's the way I approached it here. The other way of doing this, let's look at the second one. In this case, I have to multiply out the bracket. Why do I have to multiply out the bracket? Because 17 is not in the 2 times tables. If I divide by 2 now, I end up in the world of fractions. And as you'll see in task 44, the first job when you have fractions in algebra is to get rid of the fractions. We don't want to go down fraction lane. Final answer could be a fraction, that's fine. Before that, we don't want to deal with fractions at all. Right. I'm going to multiply out. I'm going to have 20. And I'm going to multiply out, and I'm going to have minus 6x is equal to 17. This time, I'm going to stick with balancing, but this time, note what I did here. If I follow the same method here, I added 6. I wanted the x to be positive, so I added x to both sides. So you could probably think I'm going to add 6x to both sides to make the x positive, but I won't. This time, I'm going to add the 20 to both sides. In other words, I want the x all by itself. So I don't want this positive 20. I'm sorry, I'm going to add 20. I'm not going to add 20. I'm going to take away 20 because this is positive 20. And I don't want the numeric value. So I'm going to take away 20 from both sides. That means on the left-hand side, I'm going to be left with the minus 6x. On the right-hand side, I'm going to get minus 3. And then as my second step, I'm going to divide both sides by minus 6. I'm going to divide both sides by minus 6. So now I end up with x is equal to minus 3 on minus 6. And minus 3 on minus 6, that means x is equal to a half. 3 on 6, that means just don't skip a step. X is going to be 3. 3 divided by 6 is 3 on 6. I can make it positive 3 on 6. That is a half. X is a half. And let's see if it works. If x is a half, then what do we have? We have 3x, which is 3 times a half. 3 over 2, which is 1.5. And then I have to do 10 take away 1.5. And 10 take away 1.5 is 8.5. So the 10 take away 1.5, that's giving me 8.5. And if I double 8.5, I multiply 8.5, 2 times 8.5, I get 17, so it's working. It's working. And no, it gets uncomfortable with fractions to do the check, but you got to do it. You got to do that check. You do not leave a room. You don't leave a test on algebra without going in reverse. The opposite of solving an equation is substitution without checking your answers. You walk away thinking, oh yeah, oh yeah. Or thinking, nah. Didn't happen. Johnny, did you get that? Did you? Yeah, that's what gonna happen. In other words, you know what the situation is because you've done your checks. That's really important. Here are 3 of these for you to do. 3 of these for you to do. You did the power of the pause. You did them. You're done. Here are your answers. Here are your answers there. Those are the three answers, okay? Um, and we're gonna move on. I was thinking I was gonna go through these, but I think I've gone through enough detail in the examples so that you have something to look back at. And again, if you're struggling with it and you can't see why you've got it right or wrong, then get teacher involved. Get a teacher involved. Okay. Now let's move on to the final piece we want in brackets for now. For now, it gets way more complicated, but for now this is where we want to stop, where because we went up to unknown on both sides, without the brackets. Now as we introduce brackets, we want to go to the unknown on both sides with brackets, and that's a good position to be in. So expand the brackets. In this situation, you want to expand the brackets, and then the question becomes just as what we were doing before, what we did in task 42, and you choose your method. If it's change the side, change the sign, or balancing. Function machines, no. Function machines, not going to happen on this. So I'm going to expand, must expand, and power the pause, get on with it. You can do this for yourself, power the pause. I've done it, I'm doing it now. You still have your chance. 2x plus 2 is equal to 6x, take away 18. I got more x's on the right hand side, so I'm going to get all the x's on the right hand side. So the 2x, positive 2x, is going to become negative 2x. That means all the numbers have to go on the left. The positive 2 is going to stay. It's the minus 18 that needs to move over, and it's going to become positive 18, and positive 2. That gives me 20. 6x, take away 2x, that gives me 4x. 4 times some number is 20. That number is 5. X is going to be equal to 5. What have I done there? I've divided both sides by 4. Divided both sides by 4. For convention's sake, I'll just change the order. Can I just make it clear you don't have to do this in exam situations or anything? But it does look prettier. So if you want to do it, that's great. But it's the same thing, whether x is on the left or the right. The fact we know what x is equal to, it's equal to 5. And we can check. We still do the check. You still got to do the check. 5 on 1 is 6. 6 2s are 12. 5 take away 3 is 2. 6 2s are 12. Yes, we have it. Let's do the other. Do I really need to do this as a pause? Just try. Just try it. The most you can do is be wrong. And let's check and learn from our mistakes, okay? Expand. Multiply out the brackets. Multiply out those brackets. Go on if you haven't done it as yet. You get 5x plus 20 is equal to 20x plus 2. I gotta get all the x's on the right because most of the x's are on the right. So what am I gonna do? Balancing method. If you're doing the balancing method, you're gonna take away 5x from both sides. If I take away 5x from both sides, what do I have? I have 15x plus 2 on the right. I have 20 on the left. Yeah, 20 on the left. Then what am I going to do there? I want the x, so the plus 2 has to go. We're going to do minus 2 from both sides. That leaves me with 18 and 15x on the right. 18 is equal to 15x. And then to finish off the job, I'm going to divide both sides by 15. Divide both sides by 15. 15 divided by 15. What do I have? I have my x. And on the left-hand side, I have, we'll stick with the blue, we have 18 on 15, and you should see those numbers are in which times tables. Which times tables has 15 and 18? Exactly, 3. We don't need, that's a job done for solve the equation, remember? Didn't say to simplify. Didn't say to write it as a decimal. But, you know, come on. You can see easily 3 goes in. Let's tidy that up. Dividing both of them by 3, I get 6 on 5. X is equal to 6 on 5. And you know what? I shouldn't even do that. If I'm doing the simplifying, I know X, you know, it looks prettier on the left-hand side. That's the convention. Put it on the left. And 18 on 15, let's simplify it. 6 on 5. So X is 6 on 5. 1 1/5, 1.2. Maybe better to think about it as 1.2 in terms of the check, but let's do it. 1.2. If I have 1.2 and 4, that gives me 5.2. So I got a 5.2 by 5. 5 5 is a 25. 0.2 by 5 is 1, so that's going to give me 26. Done that check. And you know what? I got to give you all something. I didn't mention it before. Maybe you clocked onto it, but I got to say it now. You can use the calculator. It's fine. For questions like these where it's not, and most likely it will be on a calculator paper, but as you can see, we can do it without a calculator, but if you want to use a calculator, that's fine. Okay. For questions like this, yeah, it's fine. Checking the right hand side. 1.2 times 10 will give me 12. 12 and 1 is 13. Double 13, 26. We were right. We were right. We were right. And we can check. Even when it looks a bit funny, we can check. You want to check. Now, you want to practice. Here are 4 questions. First 4 is, you'll see. After this, it gets super special. But 4 of these, work through these, expand your brackets, and use your balancing or your change side method as you see fit. Be prepared. Some of the answers would be fractions or it might be negative numbers, but work through. Use a calculator to help you to check. I'm going to pop up the answers there in a moment. I'm going to pop up the answers. So you've paused, you've had it go. Here are the answers. These are the answers you should have had. Whoa, what did I do there? These are the answers you should have had. So for A, you should have had 8. For B, minus 36 on 5. C, 3 on 2. And D, minus 33. Those are the answers you should have had. And now, you got the smile on my face, so you know what's coming. Let's finish on a really strong note. Let's stretch our understanding a bit. Here are the last 4 questions for you to do. Work through it. It's just expand. Left hand side has to be equal to right hand side. Expand, simplify the brackets, so you're using skills from earlier tasks, earlier work that we've done. Work through this, see what you can come up with as answers. Yeah, this is what it's about, isn't it? Yeah. So, okay, right now you pause, you work through them. These are the answers you should have. So F should have been minus a quarter. G is 8. X minus 5. And Z 3 on 2. So those are the solutions you should have had. What I'm going to do, I'm going to work through H. That's the one I'm going to go through as a detailed example. I'm going to work through H. So I'll leave you with that one, working through H. So let me just make some space here, clear the screen, and that's where I'm finishing up. I'm going to work through H. So, all right, let's do H. H, and remember, if you didn't do it or you didn't get minus 5, as soon as I start working through and you can spot where you went wrong or you have the aha moment, you want to stop me, pause the video, and you want to do it. You want to get that answer. You want to have that success for yourself. So, expanded brackets, you need to deal with inside. Actually, let's do inside out. I'm going to do the left-hand side. So I got the left-hand side and I have the right-hand side. I'll deal with the left-hand side first. And it means that I'm working inside out, so I need to expand it to x minus 4 in brackets first. And that means multiplying out, so I get 2x, and then 2 times minus 4 is minus 8, and I have the plus 3, and that's in square brackets. It's in square brackets, which means that it needs to be multiplied by the 2. So each term there needs to be doubled. So now I end up with 4x, take away 16. And actually, what am I doing? Take away 16. Before I double it, I should simplify the expression in the brackets. So I have 2. I have 2x. And then the minus 8 plus 3, that will give me minus 5. So double 2x take away 5, and double 2x take away 5, well, that will give me 4x take away 10. So the left-hand side, when you work through, is 4x take away 10. We now need to go through a similar process for the right hand side to simplify it. And right hand side expanding the first bracket, I get 6x and then take away 4. And now you gotta be really, really, really careful. The minus sign is affecting the x plus 1 bracket. Think of that as a minus 1. So I have minus 1 times x, which is minus x. And then was this the place that you got caught if you wanted it? Minus times a minus is a minus. So I have minus 1. Similarly, to the left-hand side, I've expanded the brackets. I now need to simplify. I have 6x's take away x. And 6x take away x will give me 5x. And then I have minus 4. So what do we have? We have minus 4 minus 1, which will give us minus 5, which will give us minus 5. So after we've worked through it, what do we have? We have 4x take away 10 has to be equal to 5x take away 5. Now, after we've done that expanding and simplifying, we could get into the solving. And we want to change sign. That's the way I'm going to do it. I have more x's on the right-hand side. So I'm going to keep 5x on the right. It means all the numbers have to go on the left. So the minus 5 is going to go on to the left. It's going to become positive 5. The positive 4x has to go to the right. So it's going to become minus 4x. That's changes that's going to happen, that are going to happen. Nothing. The minus 10 stays as minus 10. It did not change side. So now what do I have? And you can see it's game over. 5x take away 4x is x. Minus 10 plus 5 is minus 5. X equals minus 5 as required. So that is the process. That's your strategy. And I was a similar process. Different set of expansions, but you want to expand, simplify, and then you're ready to solve. Then you're ready to solve, and this is what it should look like. Right. Hope you all found that useful. We'll stop there for brackets. As I said, stop. It can always get more complicated, but that's sufficient for where we want to be right now in terms of solving equations with brackets involved.